Initial value problem. So often we run into questions where the first or second derivatives are given and we have to find the original function. That's what antiderivatives are about. But in addition to that, we may be given the initial conditions. And using those initial conditions, you can find that integration constant value c. And such a question is called an initial value problem. You'll know what I mean when I show you an example problem. So here's a very simple example problem, example 1. So suppose you have some function whose derivative is equal to 3 cosine x minus e to the 2x. Okay, let's just work with e to the x for a moment. E to the x plus 5 cube root of x. And in addition to this, you're given that f of 0 is 3. Now the question is, find f of x. Okay. How do you solve such a question? First, because f of x is the antiderivative of f prime, see, this is a function whose derivative is this much, therefore this function must be the antiderivative of this. We just think about all these functions whose derivative will be cosine e to the x and cube root of x. Okay, so let's think about this. What differentiates to cosine? Actually, positive sign, right? Positive sign differentiates to cosine. And then what differentiates to e to the x? E to the x differentiates to e to the x. And then there's the question is what differentiates to cube root of x? But this one, it's easier to use the power rule. What's the power rule? Power rule is x to the n dx. That's x to the n plus 1. And then you put the reciprocal of this number in front. So that's the power rule. And we apply it to our situation as the following. This is x to the 1/3 power, and 5 is multiplied. So if you wanted to find the antiderivative, you can calculate the integral as you add 1 to the exponent. See, it's 1 added to n. What's 1 plus 1/3? 4/3. And what do you put in front? 3/4, the reciprocal. You put the 3/4, and there's 5 there before. So you put this plus c. And that must be 15 over 4, x to the 4/3. And therefore, the antiderivative, our investigation shows that the antiderivative must be 3 sine x minus e to the x, and then plus 15 over 4 x to the 4/3 plus c. Now so far, it's exactly like finding antiderivatives, but in addition to that, we have this condition, f of 0 equals to 3. We just have to figure out what this value c must be so that this condition is satisfied. So let's think about that. You plug in 0 into this. What is f of, so from this, what is f of 0? 3 sine of 0. What's sine of 0? 0. What's the easy 0? 1. 0, you plug it in here it's going to be 0 plus c. So you end up with this sine of 0 is 0. You plug in 0, that's 0. The only thing that's non-zero is this one, which is 1. So you put minus 1 here, plus c. And that's what we get if we evaluate this function as we see it. But then what does the requirement say? The requirement says that this has to equals to 3, so we have the equality 3 must be equals to negative 1 plus c, and that forces c to be 4. And therefore we get c, we plug that c back in, and therefore we get our final answer as the function must be 3 sine x minus e to the x plus 15 over 4 x to the 4 thirds plus 4. Okay. So such a question is called an initial value problem. Sometimes people just call it IVP, initial value problem. And as you can see, the purpose of this condition is so that we know what the value of c is, so that the answer is just a single function. Okay? It's not a class of functions. If I did not have this condition, then I'll be writing this down. And this is not just a single answer, but it's a class of answers because c could be 0, 1, 2, 3, anything. All right. Now, if you could also have an initial value problem where the second derivative is given. So let's talk about that one. Initial value problem with second derivative. Example 2. What if we have the second derivative of x equals to 3 cosine x. I'll put something very similar to what we did just now. But let's keep it even more simple because I just wanted to talk about what this second derivative initial value problem is. Okay? All right, so let's say f of 0 is 3, just like before, but you'll realize that for a second derivative in the initial value problem, you also need to provide f prime of 0. So let's just say f prime of 0 is 1. So let's say you're given these conditions. I need a function whose second derivative is this, and whose first derivative evaluated at 0 is 1, and the function evaluated at 0 is 3. Okay. Can you think about such a function that satisfies all these questions? That's the question. Solution. All right, first, the antiderivative of f double prime would be f prime. If you differentiate f prime, you'll be getting f double prime. So I should be writing down the antiderivative. We already did something like that a moment ago, so let's just write down what we had before. Like we know that sine differentiates to cosine, and e to the x differentiates to e to the x. Is that right? Plus c. Plus c is the thing that you're missing. So what I wrote was wrong because I forgot to put plus c. Once you have plus c, then we're right. And then I have to evaluate, I have to apply this condition to figure out what the c is. Okay, so f prime of 0, according to what we have here, is this is 0, sine of 0 is 0, minus e to 0 plus c, so that if f prime of 0 is 1, then this is negative 1, move the 1 over here. What's the value of c? C would be 2, right? And then you plug that back in here, and we get f prime of x equals to 3 sine x minus e to the x plus 2. And then we find the antiderivative. The goal is to find f of x, so we should find the antiderivative again. What differentiates to sine? Negative cosine differentiates to sine, right? Again, e of the x differentiates to e of the x. What differentiates to 2? 2x differentiates to 2. Is that it? No, and you still have to put plus c. Now, actually, this c is, again, any constant, and it has nothing to do with this c, so to avoid confusion, often it's a good idea to just put a subscript saying that this is c1, the first of the c, and we'll call this c2. They have nothing to do with each other. Okay? c1 was the constant that appeared when you found the first antiderivative. c2 was a constant that appeared when we tried to find the second derivative. Okay? Every time you integrate, you get some constant. Okay? All right. Now, what's f of 0 according to what we have? What's cosine 0? 1. So we get negative 3, negative 1, 0, plus c2, which is negative 4 plus c2. What should this equal to?
7.
F of 0 should equal to 3, so 3 is equal to negative 4 plus c2. That forces c to be 7. And then you still have to plug it back. Now, usually when I give questions like this on the exam, a lot of students get points taken off at this stage. The reason is they stop right here. Why? Because when you get the value of some unknown thing, you get a sense of achievement, and somehow, because of that sense of achievement, you feel like, oh, I finished this question. But have you finished this? No. What was the question? It was asking for what the function was. Therefore, you can't stop here. You have to still plug that back in here and write down the final answer. So final answer is f of x equals to negative 3 cosine x minus e to the x plus 2x plus 7. Any questions?